Okay, this is section 4, crankcase, October 2023. With reference to diesel engine crankcases, explain why crankcases may have relief valves fitted, probably for extra pressure due to heating. Outline the circumstances which would cause relief valves to operate, high pressure, high temperature. State a safety detection system which may be fitted. So with reference to diesel engine crankcases, explain why they might have relief valves, why would that be operating, and a safety mechanism. That's 3 marks for the first one, 5 marks for the circumstances, and 2 marks for the detection system. So diesel engine crankcase relief valves. Why relief valves are fitted. Diesel engines operate with pistons moving up and down within the crankcase. This creates pressure inside the crankcase due to blow-by gases. Incomplete combustion allows some fuel and air mixture to slip past the piston rings into the crankcase, or badly fitted piston rings, I would have thought, or slight gaps in the piston ring. Piston movement. As the pistons compress air for combustion, the pressure within the crankcase increases. Release valves are fitted to prevent excessive buildup of pressure within the crankcase. This pressure buildup can damage the crankcase because excessive pressure can cause the crankcase to crack or rupture, leading to catastrophic engine failure. It can blow the whole thing apart. It's not designed to hold pressure. Hinder lubrication. High pressure can interfere with proper flow of oil, leading to increased friction and wear on the engine components because it's pushing the oil out. It doesn't allow the oil to circulate. It doesn't allow the oil to get where it needs to be. Which is inside, just on the inside of the piston, but not on the hot side, on the cold side, not inside the high pressure section. Part B is circumstances causing relief valve to operate. This is the big one for 5 marks. What situations would actually cause us to use the relief valve? Relief valves are designed to, but we already explained it a little bit in the first part, but relief valves are designed to open and release pressure under these specific conditions. Piston ring failure. Yeah. So worn or broken piston rings allow excessive blow-by gases to enter the crankcase, causing rapid pressure increase. So if you've got a complete failure of the piston rings break, or they come loose, or they're not in their correct position, then yeah, of course, we're going to have a much higher amount of pressure, and it will cause it to pop and therefore release the pressure. But you'd notice pretty quick. Fuel injector malfunction. A faulty injector can deliver too much fuel, leading to incomplete combustion and increased blow-by. So if you just inject a whole bunch of fuel into the piston and it doesn't burn properly, or it might burn longer than expected or something like that, which would cause too much pressure. Crankcase ventilation system blockage. The ventilation system removes crankcase gases. The ventilation system removes crankcase gases. That's a ventilation system from the crankcase. A clogged system traps these gases, causing a pressure buildup. So it's malfunctioning on the crankcase itself. So we've got piston rings failing, fuel injectors failing, or the ventilation system on the crankcase failing. For those three main points, which would cause the crankcase relief valve to operate. Okay, part C is safety detection system. Several safety detection systems can be fitted to monitor crankcase conditions and warn of potential problems before a relief valve needs to activate. The crankcase pressure sensor continuously monitors crankcase pressure and triggers an alarm if it exceeds the safe limit. So a pressure sensor, an oil level sensor, and temperature sensor. So I guess those are electronic or mechanical means. A pressure sensor could be mechanical, I suppose, but probably electronic. Crankcase pressure sensor, oil level sensor, and an engine temperature sensor. So the crankcase pressure sensor, it just checks the pressure, and if it gets too high, it lets you know. Oil level sensor detects abnormally low level of oil in the crankcase, I suppose, which can lead to an increased friction and blow-by gases, or caused by blow-by gases. Engine temperature sensor. High engine temperatures can worsen blow-by and pressure buildup. Yeah, high temperature. Yeah, so that's caused by various things, like increased friction because you got too much pressure. And so you got all 3 of them, I suppose. And they'll let you know when there's a problem. By monitoring these factors, the system can alert operators to potential issues before a situation requires the relief valve to actually be activated. This allows for preventative maintenance and helps avoid serious engine damage. All right. February 2022, outline the actions which must be taken by the on-watch engineer when the engine crankcase oil mist detector activates. Part B is sketch a crankcase explosion relief door, labeling the main components. Okay, Part A is outline the actions that must be taken by the on-watch engineer when the engine crankcase oil mist detector activates. Oil mist detector. Okay, diesel engine crankcase emergencies. Actions upon crankcase oil mist detector activation. When a diesel engine's crankcase oil mist detector activates, the on-watch engineer should follow a specific protocol to ensure the safety and minimize engine damage. Here's the recommended actions. Immediate shutdown. So we got 1, 2, 3, 4, 5. We've got 5 points. Immediate shutdown is number 1. Identify the cause, number 2. Isolate the engine is number 3. Alert others, and then do not restart is number 5. All right, so number 1, immediate shutdown. Safely reduce engine load and stop the engine as soon as possible. This removes the ignition source and prevents further oil mist generation. What is oil mist in the crankcase? I guess it's vaporized oil because it's too hot. Don't know, have to look it up. Identify the cause. Investigate the reason behind oil mist detection activation. This may involve checking for piston ring wear or damage, fuel injector malfunction, crankcase ventilation system blockage, other potential issues causing excessive blow-by gases. So yeah, it's the crankcase being too hot, having too much friction, too much fuel injected, blow-by gases, general malfunction basically. Isolate the engine is part 3. Close any valves or dampeners, isolating the affected engine from other systems to prevent the spread of oil mist. Part 4 is alert others. Inform relevant personnel about the situation, especially maintenance or supervisors. Yeah, okay, if you're on watch and you got a higher up, you want to notify them. If you are the higher up, then you have been notified. Do not restart. Refrain from restarting the engine until the cause of the oil mist is identified and rectified. Running the engine with excessive blow-by can lead to crankcase explosion. That was outline the actions that must be taken when the crankcase oil mist detector activates. Okay, part B is sketch the crankcase explosion relief door, labeling the main components. So we're going to describe it. So here's a basic sketch of crankcase explosion relief door with the label components. It's got a hinge, a diaphragm, a pressure plate. Oh, it actually says the hinge activates the diaphragm, pressure plate opens outwards. So the main components are the hinge, the diaphragm, pressure plates, and relief opening. The hinge allows the door to rotate outwards upon pressure buildup. Diaphragm, a flexible membrane that acts as a pressure sensor. Pressure plate, a plate attached to the diaphragm that is exposed to the crankcase pressure. Relief opening, an opening in the crankcase wall that allows pressure to escape when the door opens. How does it work? The functionality of it. Under normal engine operation, the diaphragm and pressure plate remain in place. However, when excessive pressures build up inside the crankcase, the force pushes against the diaphragm, causing the door to hinge outwards and release the pressure through the relief opening. This helps to prevent catastrophic crankcase explosions. So you just got to draw it. Sketch a crankcase explosion relief valve, labeling the main components. All right. October 2018. The daily engine log shows the engine crankcase pressure gauge is indicating a much higher value than the normal reading. Part A is state the implications of this and immediate actions that should be taken, and B is outline the checks and investigations that should be undertaken to ascertain the cause of this increased crankcase pressure. So that was the daily engine log shows that the engine crankcase pressure gauge is indicating a much higher value than the normal reading. So your engine, your crankcase pressure is higher than it should be. And what actions should be taken for 2 marks, and then the actual checks and investigations that should be taken to ascertain the problem, that's 8 marks. It's a lot more detailed. So the high crankcase pressure in the diesel engine, a much higher than normal reading in the engine crankcase pressure indicates a potential problem that needs to be immediate attention. Here's a breakdown of the implications, actions to take, and the potential causes. Yeah. Implications and immediate actions. Increased blow-by gases. High pressure suggests excessive blow-by gases. This is unburnt fuel and air are leaking past the piston rings into the crankcase. This can lead to reduced engine power. Excessive blow-by reduces the pressure available for combustion, impacting engine performance. Yeah, because you're not burning all the fuel in the actual stroke. Oil dilution. Blow-by gases can contaminate the engine oil, reducing its lubricating properties because you're mixing in fuel and probably bubbles and air into fuel oil into your lubricating oil. A fire hazard. Oil mist from the crankcase can create fire hazard near hot engine components. Yeah, I suppose the whole thing could spontaneously combust and it can burn outside of the pistons in the actual crankcase where you don't want it to. So the immediate action should be to stop the engine, basically, is reduce the engine load, gradually decrease engine load and prepare for a safe shutdown. So do it slowly. Investigate the cause. Do not ignore the issue. Identify the reason behind the high pressure. Alert the personnel, inform relevant personnel, especially maintenance and supervisors, about the situation, and do not restart. Avoid restarting the engine until you can identify and fix the problem. Running the engine with high crankcase pressure can lead to serious damage. It can blow up, basically. The checks and investigations that should be taken are to determine the cause of the increased pressure, conduct the following checks and investigations. We should check the piston rings, the cylinder liners, the valve train, fuel injectors, crankcase ventilation system, and the oil level and its condition. So we should check the piston rings. We should check for worn, damaged, or broken piston rings, which can allow excessive blow-by. Pretty difficult inside the engine there. You're gonna have to get right in there. Must be an easy way to check them, I suppose, right? Cylinder liners. Inspect liners for scoring or wear, which can contribute to blow-by. So see if they're scored or like broken, they have a scratch in them. Valve train. Examine valve clearances and check for any signs of sticking valves or improper sealings, which can lead to blow-by. Check the fuel injectors. Investigate the condition of the fuel injectors. A faulty injector can deliver too much fuel, resulting in incomplete combustion, increased blow-by. I reckon that would be the first one to check, the easiest one, right? Not sure. Crankcase ventilation system. Ensure the crankcase ventilation system is not clogged, as a blocked system traps blow-by gases. Oh, that would be easy to check as well. Check the ventilation system on the actual crankcase. And oil level condition. Check the oil level and condition. Low oil level can increase blow-by, and contaminated oil may not properly lubricate the piston rings. By checking all of these, you can identify the source of high crankcase pressure and take corrective actions to ensure safe and efficient engine operation. Yeah, but you got to do these things, and these, you got to check the piston rings, the cylinder liners, the valve train, the fuel injectors, the crankcase ventilation system, and the oil level, and how contaminated the oil is, the condition of the oil, but not necessarily in that order or that ease, right? I reckon some of them will be easier than others.